Hello everyone, welcome to chemistry class. Today in this video lecture we are going to start a new chapter, that is thermodynamics. So before starting with this chapter so-called thermodynamics, let's begin with the definition of the term thermodynamics. What does this thermodynamics means? And what is the importance of this thermodynamics? Why we need to study the thermodynamics? Now, the word thermodynamics, thermo stands for heat, dynamics means flow. So, the study of heat flow or heat changes in any process, whether this is chemical process or physical process. So the study of heat transfer or heat flow from system to surrounding or surrounding to system in any physical or chemical process, this is what we call as thermodynamics. So the heading is thermodynamics. So this is study of heat transfer or flow between system and surrounding in physical or chemical process. So this study of heat or energy transfer between system and surrounding, that means this can be transferred from system to surrounding or from surrounding to system. So this dynamics or this study related to heat or energy transfer is what we call as thermodynamics. Now, why do we study thermodynamics? What is the scope of thermodynamics and what are the disadvantages of thermodynamics? Now this thermodynamics basically look at this deals with macroscopic system, that means large particle. When we go to the microscopic level, then thermodynamics could not deal in the microscopic level. So thermodynamics deals with this heat flow or heat transfer or energy flow or transfer at macroscopic level only. So one of the important demerit or disadvantage of this is this deals with macroscopic system, not microscopic system. Now in this thermodynamics, we deals whether a given chemical process or a physical process is feasible or not. Means whether if suppose we are having a reaction, whether this reaction will take place or not takes place. So this is what we call as feasibility of a process. This feasibility of process deals by this thermodynamics. So if a particular process is feasible, means that is we are defining this in terms of thermodynamics, whether the system will change from one state to another state, or whether the reactants will be converted into products, or whether any physical process is taking place or not taking place. So this feasibility of process is dealt by this thermodynamics. But whether if suppose reaction is taking place or if any process is taking place, how fast the process will take place, up to what extent the process will take place, or what is the speed of the reaction or the process or the rate of reaction. This speed, this rate of reaction or the process cannot be decided by this thermodynamics. It only deals whether the process will takes place or not takes place. That is the scope of thermodynamics. So any process will occur or not occur under a given set of conditions that will be decided by this thermodynamics. But if the process is taking place, how fast the process will take place, up to what extent the process will take place, what is the speed of reaction, what is the rate of reaction, that cannot be decided by this thermodynamics. So basically we are doing for a chemical reaction. So in this chemical reaction, how the system changes by transfer of heat or this energy within the system and surrounding, that can only be explained by this thermodynamics. Any type of heat transfer or energy transfer can be dealt by this thermodynamics. So this is the scope of thermodynamics, the advantage or disadvantage of thermodynamics. Now, having learned this scope or advantage or disadvantage of this thermodynamics, before starting with, now we have to be familiar with some basic terms that we often use in thermodynamics. So coming to the basic terminology, basic terms used in thermodynamics. So the first term that comes to our mind is universe. So universe is a basic term which is often used in thermodynamics. So universe in thermodynamics consists of two parts, system and the surrounding. The combination of system and the surrounding, this is what we call as universe. So this is system plus surrounding is what we call as universe. So we have a term which is known as system and the surrounding. So the combination of system surrounding we define as universe. Now the question is, what is system and what is surrounding? So coming to this, system is defined as the part of universe in which the investigation is being carried out. So we have a universe. In this universe we have a particular part. In this part we are focused only in that part, and in that part we are carrying out our investigation or we are carrying out the reaction. So that container in which the reaction is being taking place, that is what we call as our system, and the outside, that the room, that will consider as a surrounding. That means whenever we carry out a chemical reaction, we carry out chemical reaction in a test tube. So that test tube inside which the chemical reaction is being taking place, that is what we call as our system, and outside that test tube, that consists of the laboratory room, that room consists of the surrounding. So any part of universe which is being investigated, that is what we call as system, and the rest of the universe apart from this system is known as surrounding. So we have this system, it is part of universe being investigated, part of universe being investigated, that is known as universe, and surrounding is the rest of universe except system. So if we exclude system from the universe, then the rest of the universe is what we call as surrounding. So I hope this is being clear. So whenever we are sitting in a classroom, let me just give you an example. Okay, whenever we are sitting in a classroom, that classroom is the a particular classroom of a particular section. So that is our system, and the rest of the college or the school, that is our surrounding. So that school or the college makes up our universe, and in this universe we are sitting in a particular classroom in which the lecture is being going on, and that classroom consists of our system, and the rest of the school excluding this system, that will be considered as a surrounding. So in chemical process, what we are saying is the part of universe in which the chemical process or the physical process or the chemical reaction is being taking place and which is under investigation, that is known as system, and the other part of this system is universe other than system, that is known as the surrounding. So this is the concept of system and surrounding, and in all this process, thermodynamic process, we are going to deal with the system only. What is happening, what is going to happen in the system, that we are going to deal in the thermodynamics here. So we have this system and this surrounding. Now this system can be of different types, that is types of system. We have open system, we have closed system, we have isolated system. So we have three different types of system that we are going to focus here. So coming to the first, open system. So in an open system, there is free exchange of or free flow of heat and matter between system and surrounding. Free exchange of matter and energy between system and surrounding. So that consists of an open system. That means when we have an open system, in this open system there can be exchange of energy between the system and surrounding, and there is also exchange of matter, means the amount can be exchanged between system and surrounding. That is what we call as open system. If you take it, this example, liquid heated in an open container. Open vessel. Suppose we have looked at this. This is an open container. We heat this, then between this system and surrounding, we have this is our system, this is our surrounding. Now because what is happening inside this container, that we are going to deal, and this is our system, this is our surrounding, and between this system and surrounding there is free exchange of matter and energy. So energy can be exchanged between system and surrounding, and the matter can also be exchanged between system and surrounding. So whenever we have this type of process system, then we say this is open system. So when we heat this container, we can increase or decrease the. If you cool the system, energy will decrease. If you heat the system, energy will increase. Accordingly, if we heat this, some of the particle will escape out. As the particles will escape out, the quantity or the matter inside this system will increase or decrease depending on the change in temperature. So there is exchange of energy and matter, free exchange between the system and surrounding. That type of system is what we call as open system. Now coming to second, that is closed system. In a closed system, only the energy can be exchanged freely with the system and surrounding, but the matter cannot exchange between system and surrounding. So only free flow of energy between the system and surrounding, that is what we call as closed system. Example, liquid heat placed in a closed container. If you heat this container, closed container, we can increase or decrease the temperature, means we are transferring energy between system and surrounding, but the quantity of liquid inside the container cannot change because already this container is being sealed or blocked. So that is what we call as a closed system. So in this closed system, only free exchange of energy takes place and metal cannot exchange. So example, liquid heated in a closed container. So we have this container is sealed, this is our system and the rest is our surrounding. So we have system, this is our surrounding. So between this system and surrounding there is exchange of energy, only energy exchange, but between this system and surrounding there is no exchange of matter. Matter cannot exchange between system and surrounding, only the energy can exchange between system and surrounding. So these consist of a closed system. Then we have this isolated system. In an isolated system, there is no free exchange of energy and matter between the system and surrounding. So यहाँ पे this isolated system means no free exchange of energy and matter, no free exchange of energy and matter between system and surrounding. Means neither energy nor matter can exchange between system and surrounding. That is completely isolated. Means it has no interaction with the surrounding. System has no interaction with the surrounding. Completely isolated. Example, liquid placed in a thermos flask. So if I say liquid placed in a thermos flask, this is nearly isolated, not 100% isolated. When you place a hot liquid in a thermos flask, the liquid remains hot for a certain period of time. After that, liquid becomes slowly it becomes cool down. So that means up to certain extent we can say this represents an isolated system. This is just an idealized concept. This cannot be 100% or perfect isolated system. So for this, this is our system and the rest is our surrounding. So no energy and matter, neither energy and nor matter can exchange between system and surrounding. So no exchange of energy or matter between system and surrounding is possible. This is what we call as isolated. So we have these types of system. Apart from this, we also have homogeneous system and heterogeneous system. We also have, look at this, homogeneous system. In an homogeneous system, there is a uniform composition throughout the system. Means when we take of chemical substance, there is a chemical composition that remains uniform throughout the system. That type of system is known as homogeneous, like unpolluted air. Whenever we have unpolluted air, the composition of air, that is 78% nitrogen, the rest oxygen plus or less than 1% other gas, this remains same. But if there is a pollution, then this composition may differ. So that represents an homogeneous system. So homogeneous system means uniform composition throughout. Uniform distribution or composition. Uniform distribution or composition of matter throughout the system, that is known as homogeneous. Example is unpolluted air. Then we have heterogeneous system. Heterogeneous system. Heterogeneous, if homogeneous says uniform distribution or composition of the matter throughout the system, then heterogeneous system represents in which there is non-uniform, or if the distribution or the composition of the matter throughout the system is not uniform, then we say this is heterogeneous system. Example, I asked told you, if unpolluted air represents homogeneous, then polluted air represents heterogeneous. That is non-uniform distribution or composition of matter throughout the system, that is what we call as heterogeneous system. Example is polluted air. So this is homogeneous, heterogeneous, apart from this open, closed and isolated system. So now look at this, we are talking about this system and surrounding. Now we define this system is the area or the space or the region of universe in which the investigation is being carried out. Now then we can always imagine a boundary, a separation boundary between the system and surrounding. We can always imagine, but this boundary that exists between the system and surrounding, that boundary may be a real boundary or maybe an imaginary boundary, but we can always think of a boundary between the system and surrounding. So we have this system. So we have a system. Suppose this is our system and this is our surrounding. So this, the wall that separates the system and surrounding, this wall, this is the wall which separates the system from surrounding or the surrounding from system. This wall which separates the system from surrounding, this wall is known as boundary. So this boundary which separates the system from the surrounding, this boundary may be real or may be imaginary. So we can always think of a boundary or a separating wall between the system which may be real or which may be inner, but we will assume that there is always a boundary between the system and surrounding. So this is system, surrounding, universe and types of system. Now once we know the system, then next we come to one, what is the process? What is process and how different types of process exist in thermodynamics? So coming to the process, so first of all let's define what is the meaning of process. A process is defined as a transformation in which the system changes from one state to another state. So whenever a particular system is to be changed from one state to another state, we have to perform some transformation. That transformation or the task which is used for changing the state of the system, that is what we call as process. So let's define it. This is the transformation or the task used to change the state of the system. That means we are changing the state of the system. Yes, we are moving from one state to another state. So when these systems move from one state to another state, what is the transformation, what is the task we perform on the system so that this is changing from one state to another state? That transformation or the task or the operation is what we call as process. So any given process, there must be some task in which the state of the system has to change. That is what we call as process. So I repeat the term again. When the system changes from one state to another state, what is the operation that is being carried out, or what is the transformation that, or the what is the task that we do on the system so that it changes its position from one state to another state? That is what we call as process. Now these process may be of different types. Types of process. So we have different types. First of all is isothermal. Isothermal process. So we use a term isothermal. So isothermal means when the temperature remains constant during the whole process, during the whole transformation in which the system is moving from one state to another state, temperature of this system remains constant. So any process in which the temperature remains constant, that is known as isothermal. So temperature T remains constant. If temperature remains constant, that means initial temperature is always equals to the final temperature. If initial temperature is equals to final temperature, means delta T, which is defined as Tf minus Ti, will always be equals to 0. So any process in which the temperature remaining constant or initial and final temperature remaining same or delta T equals to 0, that process is known as isothermal process. Then we have isobaric process. In an isobaric process, pressure of the system remains constant. Here, pressure remaining constant. So pressure remaining constant, that means when the system containing ideal case changes from one state to another state, the pressure, initial pressure is always equals to the final pressure. If initial and final pressure remains same, then delta P, change in pressure, which is defined as final pressure minus initial pressure, will always be equals to 0. So that process in which pressure remaining constant is defined as isobaric process. Then we have adiabatic process. So in an adiabatic process, there is no heat transfer between system and surrounding, or the heat remains constant. So in this heat, or heat is defined as Q, so heat remains constant. So that particular process in which the heat content of the system remaining constant, that is known as adiabatic process. If this is case, then delta Q will always be 0. Change in heat transfer between the system and surrounding will always be 0 because heat remaining constant during the process. Number 4, isochoric process. Isochoric process, a process in which the volume remains constant. Here the volume remaining constant. So suppose we are having an ideal gas which is changing its state from initial to final state. During the process, the volume of the gas remaining constant. If the transformation is carried out keeping the volume constant, that is known as isochoric process. So in an isochoric process, initial volume is equals to the final volume. That means delta V, change in volume, which is defined as final volume minus initial volume, this will always be 0. That is what we call as isochoric process. Then we have cyclic process. Cyclic process means a process in which after a number of transformation comes back to the initial state. Though there is a transformation, but after a series of operation, this system comes back to the initial state. That is what we call as cyclic process. System comes back to its initial state after a series of transformations. Though there is a transformation, but after a series of transformations, system is coming back to its initial state. That is what we call as cyclic process. Suppose look at this. This was the initial state and this is also the final state. We are having this transformation. So this point is your initial as well as final state. This is initial as well as the final state. So in a cyclic process, the initial state is always equals to the final state, though there is a transformation, but after this system is reverting back to initial state. That is what we call as cyclic process. Then we have a reversible process. A reversible process. So all the reversible process, whenever we use the term reversible process, all reversible process takes place very slowly, and it takes infinite numbers of steps to complete the operation. So the first thing is, all reversible process takes place very slowly, very slow, and takes place in infinite number of steps. So all the reversible process takes place very slowly and it takes place in infinite numbers of states. Whenever we have a reversible process, there is always an equilibrium between the system and the surrounding. Means initial state and the final state, there is always an equilibrium. And equilibrium state exists. That is, suppose this is the initial state and this is final state. So in between these two there is always an equilibrium state. That is the meaning of sign of a reversible process or equilibrium state. So the system being very slow and takes infinite numbers of states, this cannot be 100% completed. The moment initial state is converted into final, final will again convert into initial state. So this process keeps on going, and because of this the process is very slow and it requires infinite numbers of states to occur the change. That is reversible process. Now look at this. If you look at this, now the system is moving from initial to final. So there is some driving force which forces this initial to the final state. That is what we call as driving force, which forces the system at initial to change to the final state. Along with this, the final state is also changing into initial state. So this final into initial, that force is known as opposing force. So when system moves into final state, some force is operational, that is known as driving force. Along with this, look at this, the final state is also opposing the change, that opposing force is known as opposing force. So the driving force and the opposing force, it is driving force means for this forward reaction, opposing force means for this revert reaction or the backward reaction. So the driving force and the opposing force is approximately same, or we say driving force is infinitesimally larger than the opposing force. That process is known as a reversible process. So if you look at this force, those particular force which force these initials to change into final state, that is known as driving force. And the one which opposes this driving force, that means final to initial, that is known as opposing force. So both are operating simultaneously. So for a reversible process, the driving force, that is the driving force is approximately same as that of the opposing force, or we say the magnitude of the driving force is infinitesimally greater than the opposing force, or the magnitude of driving force is infinitesimally greater than opposing force. That means when we compare, the difference between this driving force and opposing force is approximately same, or that is 0. That means this driving force minus opposing force, this is approximately 0. So when we compare the magnitude, though system is moving from initial to final, so driving force might be slightly greater than that of opposing force, but this is approximately same, so difference may be approximately 0. That type of process is what we call as the reversible process. So keep this thing in mind. Whenever we have this reversible process, the magnitude of driving force is approximately same as that of opposing force. Second, all this reversible process must take place in infinite numbers of steps, so process will be automatically slow, and this reversible process can never go to the completion. So this is a reversible process, and we told not a process is 100% reversible, but this is again idealist concept. We can consider the system to be under reversible process under certain restricted condition, that is a reversible process. If we have reversible process, then we also have irreversible process. Irreversible process. If reversible is slow process, irreversible is fast process. If reversible takes an infinite numbers of steps, reversible takes finite numbers of steps. An equilibrium exists in reversible process, but in case of irreversible process, that is unidirectional, system is taking from only from one portion to another portion, that is one direction only, and the magnitude of driving force is much better than that of the magnitude of opposing force. So these are the parameters of reversible process. That is a fast process and takes place in a finite number of steps. Second, this is unidirectional, that is initial is always changing into the final state. This is moving in a particular direction, while this is moving in both directions, initial to final, final to initial. But in case of irreversible process, each system is in a particular direction. When we compare this driving force and the opposing force, the magnitude of driving force is much greater than the magnitude of opposing force. So this is the reason why this is a unidirectional process. And all naturally occurring process is irreversible. All naturally occurring process is an irreversible process. So this is the types of process that we often encounter in thermodynamics. So we have defined what is process, what are the different types of process. Now after learning this process, then we are left with some other basic terms. So that is next part. Then we have state functions. State function or variables. So state function or state variables, these are the variables which defines the state of the systems. So those variables which defines the state of the substance, that is known as state function, and these state functions depends on the initial and the final state. How does initial state changes to the final state, that is immaterial, but what is the value of those parameters in initial and final state, that is known as state dependent. Initial and final state dependent, irrespective of the path that is being used for this transformation, that is what they call a state function. So this is variables which defines the state of the system. If we take an ideal case, so an ideal case is defined by pressure, volume and temperature. So for an ideal case, variables are pressure, volume and temperature. So once we know the pressure, volume, temperature, we can easily define the state of the system ideal case. So these state functions, these are known as state functions or state variable. State functions depends only on the initial state and the final state and is independent of the path taken for the transformation. Depends only on the initial and the final state of the system and is independent of the path taken for transformation. So those are known as state functions or state variables. So example, we have energy, we have enthalpy, we have internal energy, we have entropy, we have free energy. These are all known as state functions. So we'll discuss this thing in later on. So these are state functions or state variables. Then we also have path function. Path functions are those functions which depends on the path taken or the route taken for the transformation and is independent of the initial and final state. Those are known as path function. Depends on the path or route taken for the transformation and is independent of the state of system. Those are known as path function, and this under this we have example work done and heat. This depends on the route taken for transformation and is independent of the initial and final state. This is what we call as path function. So we have two types of functions, state function and path function. State function, state dependent, path independent. Path function, path dependent or state independent. Then we have intensive quantity. Intensive variable or extensive quantity or intensive variable. Intensive quantity or intensive variable are those variable which is independent of the amount, independent of the mass or independent of the amount of the system, that is known as intensive. So intensive, amount or mass independent. So any variable, any term, anything which is independent of amount or mass of the system, that is what we call as intensive variable or intensive quantity. And this intensive quantity is non-additive. That means you cannot add these quantities to find the final value, non-additive. Example, look at this temperature. Temperature is independent of the mass of the substance, independent of the amount of the substance. Then we have look at this cell potential, and then this one plus EMF. Then we have specific heat capacity. We have look at this. We have density, So look at this. These are those those variable which is amount independent and they cannot be added or subtracted. That is known as intensive quantity. Then we have extensive quantity. These are the quantities which are amount or mass dependent. Amount or mass dependent. That is extensive. The extensive quantities are additive in nature. You can add to find the final value. We have this example: energy, we have enthalpy, we have entropy, we have free energy, we have volume, we have heat capacity. So these are the certain terms that we find in which this depends on the quantity of the substance or the amount or mass of the substance. So these are known as extensive quantity, intensive quantity. So this is intensive and extensive. Then we have some other terms. Heat and work. Work done. Work done is any form of heat transfer, energy transfer between system and surrounding. That is what we call as work done. Energy transfer, any form of energy transfer between system and the surrounding. So any form of energy transfer between system and surrounding is what we call as work done. So work done, whenever we use the work done, work is always done at the boundary of the system. Work is always done at the boundary. At the boundary wall of the system. If the system is doing work, then at the boundary. If the surrounding is doing work, then again at the boundary of the system. Now this work done is of two types. One is work done by the system on the surrounding. So work done by the system on the surrounding, simply say work done by the system. Work done by the system. So work done by the system. So this work done, sign convention says this sign work done should be negative. So if I use the term work done by the system, the convention says the unit of work done should be minus. The another one is work done by the surrounding on the system, or simply say work done on the system. So first one is system is doing work on the surrounding, so work is negative. The other one is surrounding is doing work on the system, so work done on the system by the surrounding, or work done by the surrounding on the system. So surrounding is doing work on the system. So for this, the sign convention is work done should be positive. So sign convention says if work is done by the system on the surrounding, that is negative work. If the surrounding is doing work on the system, then the convention is positive. So work done by the system, internal energy decreases. If the system is doing work on the surrounding, energy content of the system will decrease. But if work is done on the system by the surrounding, then internal energy increases. So this is the convention of work done. Now, for ideal case, we define work done in terms of pressure work, that we'll take up later on. Then we have this heat. We also use the term heat. So unit of work done. Normally work done is nothing but the energy, so unit is joule. Joule is the standard unit of energy, or sometimes we also use calorie, etc. Then we have heat. Heat, we represent this by Q or small q. So this heat is also energy transfer between system and surrounding, but by virtue of temperature difference between the system and surrounding. This energy flow occurs between the system and surrounding only when there exists a temperature difference. That is what we call as heat. So this is energy transfer between system and surrounding by virtue of temperature difference. So the heat is defined as the energy transfer between the system and surrounding by virtue of temperature difference. So this transfer of heat through system surrounding only when temperature exists, that is known as heat. Now the unit of heat is conventionally taken as calorie, but if you look at this, calorie is also the work done but non-standard unit. So this is heat. Now heat transferred to the system, if heat is transferred to the system or heat absorbed by the system, internal energy increases. If heat is transferred to the system or system absorbs heat, then Q will be considered as positive. So if heat is transferred to system or system is absorbing heat, the sign convention will be positive. If heat is transferred to the surrounding, means system is transferring heat to the surrounding, or system releases heat, then the convention of heat will be negative. So heat released by the system, heat is negative. Heat absorbed by the system, heat is positive. So this is the main difference between heat and work done. Though both are energy transfer between system and surrounding, this is the generalized transfer. Unit is joule. This is transfer by virtue of temperature difference, that is defined as the heat.